Hey guys, welcome to Digital Srini channel on YouTube, and I'm back with another video that is part of my Python tips and tricks series. And if you are a regular viewer of my channel, you know that this series, the videos are released on Saturdays or Mondays and not on Wednesdays, which is when my regularly scheduled videos are released. And why am I doing this? Because I don't want to confuse this with the other topic. The ones that I release on videos, I schedule them at least 2 months ahead of time. I record them, I test them extensively, and they are part of a series in general that I think is beneficial to the viewers of my channel on a continual basis. These are the ones where I find some topic to be very interesting, intriguing, and maybe new in some cases, and I'm like, oh, my viewers would absolutely love to know about this, and that's why that's when I record this video. So this is part of that. And here I'm going to talk about COVID vaccination progress, and there is a good database, data set, I should say, that we can use that gets updated on a constant basis to understand the COVID vaccination. Now, this tutorial is more about using pandas as a tool to extract information, and COVID vaccination is just an example that all of us can relate to, so we can learn two things at the same time: pandas, and also what's going on with COVID vaccination in my country, in the world. Okay, let's try to make this not a very long video, but I'll try not to rush. So let's first look at the dataset itself. There are many sources for COVID vaccination data out there, and I was browsing through Kaggle and I found this one, COVID-19 World Vaccination Progress. This seems to be updated quite on a regular basis. This one was updated 9 days ago, which right here it says October 27th. So hopefully we'll have data up to October 27th, 2021. I'm recording this on November 5th. So I'm probably you're seeing it on November 5th or November 6th whenever I'm done editing this video. This is the advantage of tips and tricks videos. I want to get them out to you right away. Okay, so what does this dataset contain? Well, it has the country name, the ISO code and date, and the total number of vaccinations for that specific date. In this case, it says 0. This bothers me. There is nothing there, nothing there, nothing there, nothing there, nothing there, which means there is a lot of empty data empty cells, let's call it, that we need to take care of. We'll talk about that once we get into the code. Okay, there are a lot of columns. How many columns? You can go down. There are 19 columns in this data set. Okay, so all you need to do is sign up for Kaggle, and then you can just click on download. You get it, and that's what I uploaded to my Google Drive. And the code here, let me zoom in a bit so it makes it easy for you to see. The code here, I'm going to share it. Again, look at the description for the link to my GitHub page. Okay, let's get started. Like I mentioned, import NumPy and pandas. I do that all the time. It doesn't matter what data. I may use NumPy or not. I'm definitely pandas for structured data. I'm going to import these two right away. And you can install Plotly if you want, and this makes it easy for you to plot, especially choropleths. What do I mean by choropleths? Well, world map or your local map, whatever the map is, on the map you're putting some data. That's what a choropleth is, and Plotly makes it easy for us to do. And I'm not installing it here because I found out that Google Colab already comes with it, and if it's not, then go ahead and uncomment this and run this line. So let's move on down here. I'm importing a few libraries. Matplotlib is the one that I love, absolutely love, and Seaborn is on top of Matplotlib PyPlot. It makes certain type of plotting easy. So I'm just importing both of these libraries, including Plotly. So let's go ahead and run those. So far, no surprises. I'm not going to talk about the basics of pandas. If you really don't know the basics of pandas, I really want you to go back to my videos on this topic, because this video may not make too much sense to you. Please go ahead and watch it if you want, but to really get the essence of this video, it helps if you have some knowledge in pandas. I'll try to explain a few things, but really not to the point where it's too basic and some other viewers get too bored. So first of all, we have a CSV file. We need to capture that as part of a pandas data frame. So pandas is like people will kill me for saying this, like Excel, Microsoft Excel for Python. Sorry guys, it's a false equivalency because pandas can do a lot more and make things a lot more easy. But anyway, that gives you an idea of how pandas can be used to handle structured data. Okay, so in this case, my file is located right there. I have already connected my Google Drive, so I know exactly where this file is, and I am reading using pandas.readcsv. So let's go ahead and run this line, and then let's look at, first of all, let's look at the head. What does df.head do? It gives you the top 5 rows. So let's go ahead and print them, and you see the top 5 rows: country, ISO code, date, total vaccinations, people vaccinated, people fully vaccinated, daily vaccinations. There's so much information that you can use to play with to get the insights you're trying to get from this data. In my view, in this exercise, the insights that I'm trying to gain is, let me pick 2 countries, US and India, and how many people are vaccinated and how many people are per 100 are vaccinated, and this type of data is what we are going to explore later on. In addition to that, also we are going to look at the world, like in the world, like who are the top 10 countries that are very efficient in vaccinating their population. When I say very efficient, that means if you just look at total vaccinations, then it's like, oh, China and India are the top 2. Well, is it top 2? If you divide them by, if you look at what are the columns? Is there? I think there's a column total vaccinations per 100 people. So for every 100 people, or total vaccinations divide by 100, like how many? Who is the top one? So we're going to use all of that, and we have to take care of this not a number, because you have to find a way to deal with them. Either drop all of these not in numbers or fill them with some value. In our case, let's go ahead and start by filling them with value 0 and then drop them later if needed. But first, let's fill them by 0. I don't like to look at this not in numbers. So that's what I'm going to do first. But first, let's figure out how many of these nulls are there. If you just not use this sum.sum and only do df.isNull, all it's going to do is it says, hey, this is a null, this is a null, this is a null, but it's not going to tell you how many. So use this .sum to figure out how many of missing values are there. So obviously, as you can see, total vaccinations, 24,000. These are all missing null values. So let's go ahead and fill them with zeros and then deal with them later. Deal with the zeros later. Meaning, hey, if my date, for example, oh, actually, none of my all the rows, they have the date. If some of the dates are ISO code, for example, if some of these are null values, what do you do with data that doesn't have a country code? I don't know what to do with it, so let's go ahead and drop it. So these are the things we'll do later on. Even though I know there is nothing null, I'll show you the process so you can use it somewhere else. Okay, first thing first, we have to take care of this nulls. So let's fill them with zeros. So how do you do that? Our data frame, we gave it a name df, right? .fill NA. It's going to fill it with whatever value you give. So we're going to give it a value of 0, and I'm putting in place equals to true because I'm not saying df equals to you. Another way you can do it is that, in which case you don't need that in place equals to true. Basics, but let's just go ahead and delete that. And I just mentioned if ISO code equals to 0, go ahead and drop it. Yeah, go ahead and drop that. Let's go ahead and include that. It's not going to make any difference right now, but it is going to fill all the null values with 0 right there. So if I run it, you'll see that these are all zeros right there. So that means now we have nothing that's null. So let's go ahead and proceed. This is typically how I work with structured data. Take care of the nulls, and now let's go to the next level. Go ahead and look at isNull. We already did that. None of them are null. The next thing I usually do is either df.info or describe. It gives you a good understanding of your data set. Describe gives you a lot more data, but info is good in this case because the intention of doing this is it's going to tell me how many non-null data points are there. So total, there are 53,595 data points that are not null. A bunch of them could be zeros because we just replaced them with zeros. but that's what we have here. More importantly, the reason I'm doing this is to understand the data type. If you look at all of these are all numbers, actual numbers that we want to work with. They're all floating point 64. So the system understands that these are numbers. If you look at these vaccines, source name and source website, this is text. Vaccines is like, is it Pfizer? Is it Moderna? Is it Sinopharm? What vaccine is it? So that's text. Source name is it, where is it the numbers coming from? Is it Government of India, for example, or Ministry of Health? Whatever the source name. We don't need those, but anyway, that's the text right here. Same here. Country is text. ISO code is text. Unfortunately, it thinks date is text, because our date is in the format of 2021-02-22 or something of that sort. We need to convert that into a date time format, so it makes it easy for us to plot later on. So let's do that right here. So my date column replaces all the values to a format of year, month, and date by converting them to date time format. So once I do that, you'll realize, let's go ahead and plot this one more time. You'll realize that my date is now not an object, but date time format. Okay, so let's move on. And the next thing we need to do is, we have a lot of data. Let's say I don't need some of the columns. Let's go ahead and drop them. So first of all, let's have a quick look at the columns. We need the country, we need the ISO code for plotting, even for getting insights. We need date, we need total vaccinations, because I want to look at how many vaccinations China did, how many did India do, and so on. And we can drop this people vaccinated, people fully vaccinated, or we can leave this and just drop fully vaccinated. If you want, you can keep it. If you want to analyze partial vaccination versus fully vaccination, like 2 shots and so on, you can leave that. But some of these are useless, especially the source name, source website. Let's go ahead and drop them. So that's what I'm doing as a next step. Drop some of these that we think are not useful for us. Next, now I'm going to pick US for my first country and India for the next one. I'm going to do exactly the same analysis for both. So let's start with US. First of all, how do we extract only the US numbers? Go back to your data frame. If the ISO code is equal to USA, copy that data frame, into a new data frame called df_US. So let's do that. And here it is, all the data for US. Again, one thing that should bother you if you look at this is, look at total vaccinations. It started off with 556,000, 614,000, and then 0. And then 1,000,000, and so on. Now, this is total vaccination. This should always go up because it's a cumulative. So this 0 is there because originally it didn't have any data. We filled it with 0. So first thing first, we need to remove all the rows where it's a value of 0, so we have a continuous number. So that's what we need to do. Again, this is something that you have to look at this and then make these decisions. So let's go ahead and do that. So that's exactly what we are doing right there. If the total vaccinations equal to 0, go ahead and replace, drop that right here in this data frame. So that's what we are trying to do here. And you can go back and look at exactly the same. Let's run this line. No, let's not run that line. Then it copies that. Again, if you want, you can print and see if the zeros are gone. But let's go ahead and plot it. How do you do that? Again, I'm using Seaborn here, but it can be regular matplotlib. I'm using Seaborn because it makes it easy for me to plot a line plot using this data frame and that column as X and this column as Y. And these are the titles, that's it. And let's go ahead and print it. And you see the vaccination rate increased all the way up to about May timeframe. And then it started to flatten out. This is almost like a sigmoid curve. Yeah, it's unfortunate because this is flattening out and this needs to go up if we want more of the population to be vaccinated. I mean, it saturates at some point. When everyone is vaccinated, it saturates. In the case of US, I believe it is 70% about, who are vaccinated, and it's flattened out. This is not good. And they just started to vaccinate younger kids, so I'm hoping this would go up. So let's look at how the daily vaccinations happened. Like not a cumulative vaccination, but per day, each day, how many people got vaccinated. you can infer that if you come from some math or physics background, you know that you have a curve right there. And how do you get daily vaccinations? I mean, if you want to do it in a mathematical way, I believe it is the first derivative of this, which gives you a peak right around here and then goes down. I think that's what we expect, but in this case, we are not doing it in a mathematical way. We are doing it by using actual data that we have, so we don't have to do it the other way. Anyway, so now let's go ahead and plot our daily vaccinations, not total vaccinations. So every day, exactly the same type. So let's go ahead and click here, and yeah, obviously it follows the mathematical model that we predicted earlier. So it goes up, comes back down, and almost flattening out. I hope this goes back up again. Okay, so this is how things are happening in the US when it comes to total and also daily vaccinations. You can get a lot more information from this, but these are the two I chose to work with right now. Let's do exactly the same with India. Copying the data frame and dropping all the null ones. So let's go ahead and drop the null right here. Total vaccinations, if they are 0, go ahead and drop them. And let's go ahead and plot, what am I doing here? Total vaccinations. Yeah, let's go ahead and plot this. I don't know why I did this twice. India's total vaccinated population trend. I can delete this part later, but let's not worry about it. Let's do it here. First, you see how it's still increasing. This is an encouraging sign. This is actually very good considering the population of India and also the complexity of reaching out to certain remote areas. So it seems to be doing a great job in vaccinating the population right there. Okay, how is it going on a daily basis? Let's go ahead and plot that out. And here how it is, it's on a daily basis. It doesn't look very consistent. If you look at the US, it looked peaked and fell down. Of course, you have some variations on a daily basis, but this one is a lot of variations. So initially, if I look at this without knowing anything, I would look at some of the peaks and say, oh, that's good. Why did it fall? That's good. Why did it fall? Is this a supply and demand case? Is it like the government cannot supply any more vaccinations, so it went down? Or is it the population doesn't want to take vaccination? I don't know, but these are some of the insights we need to extract by adding additional information. If you really are curious about studying this, or if you want to get into financial analysis type of thing, the best thing to do is go back to that specific date. Like we have our data frame, right, for every day, and go to a source where you can get the top 5 headlines for that day, news headlines, and attach them to your data right here. And then you can, with Seaborn, for example, you can actually, or with Plotly even better, you can plot them such a way that when you hover your mouse on the peak or on a day, it gives you the information. So right here, it could be that, hey, the government is struggling to supply vaccinations. Yeah, so that could be the issue. So anyway, either way, there's a lot to study here. Maybe my guess is right there, it started to vaccinate like older people first, and then like they reached the peak, but then they have a gap between going from older to like younger and so on. Maybe it fell down. I really love this type of graphs because now you can go back and really study a lot. I'm very much curious about why there is a dip right there and why it came back up. Okay, so enough talking about that, and this we already plotted. Let me go ahead and delete this. And now let's move from individual country to overall in the world. What are the top 10 countries with highest vaccinated people per 100 of the population? Why is this important, per 100 of the population? Like I said, if you only look at the total number of vaccinations, then China and India, even like maybe US and Brazil, these would be the top countries because they have the highest population. But are they the most efficient ones in vaccinating its people? Meaning, per 100, are they the best ones? So to do that, all you need to do is look at total vaccinations per 100 and go ahead and plot it. I'm not going to do that right away because if that's the case, it gives you misleading information sometimes. For example, if a country like Liechtenstein that probably has, I don't know, 50,000, 100,000 people, it's very easy for them to vaccinate everyone. So we cannot just say that, oh, these are the best guys at vaccinating its population. Yes, they are. But you have to compare that with their regular vaccination. So what I'm trying to do here is get the top 10 countries that have dispensed the most number of vaccinations to its population. So, or you can go to top 20. It's up to you. I picked top 10 just to get the top 10 countries that has delivered the most vaccinations, and of those, who are the most efficient. That's the exercise I'm trying to do. So first of all, we want to group them by what? By country. So go ahead and use your pandas data frame, group by the country, and then sort these values. Yeah. Sort these values by total vaccinations in a descending order. That's what this line does. And this is doing it for every country. And then get only the top 10 countries and print. That's what I'm doing right there. And you'll see that, as you can imagine, China, 2.25 billion vaccinations have been delivered so far. Amazing, incredible. Same with India, 1 billion. That means at least 500 million people got vaccinated, assuming each person gets 2 vaccines right there. And then US, about 415, is that 415 million? I guess so. That looks like it. And so on. So this is the top 10 countries. And you can see what vaccines are used and so on. Now let's go ahead and sort this data based on total vaccines per 100, because this doesn't mean China did the best job or India did second best job in the world. If you actually look at total vaccines per 100, China is 155 vaccines and then per 100 people. And India actually did only 74 vaccinations per 100 people, and then comes 123 right there, and so on. So let's sort them. Let's sort them based on total vaccinations per 100 in a descending order. There you go. And now you can see China came first, Japan came second, and so on. You can look at the data, but it's easy to plot. So let's use our matplotlib pyplot.bar. What are we going to plot? We are going to plot vaccine by country .index, y.index, because when you do this group by, it's actually, what did we group by? Definitely country. When you do group by country, it automatically makes that your index. Yeah. So previously it was your country was your first column. Now it is your index instead of 0, 1, 2, 3. So hopefully that makes sense to you guys. So that's what we are doing right here. We are plotting by the index, which is our country, nothing but our country. And then what are we plotting? Total vaccinations per 100. And we are plotting it in bar. And let's go ahead and plot this. So there you go. So China first, Japan. I'm surprised by Turkey. I should admit I haven't paid any attention to Turkey. If there are any viewers out there, you should be very proud of how the vaccinations, how your maybe, I don't know who is, taking care of vaccinating the people, but they seem to be doing a decent job right there. And comes Germany, Brazil, US, Mexico. India is right there in the top 10. But again, it's a challenge for large countries with extremely large populations. China is doing a great job, and comes Indonesia and Pakistan. In fact, for this type of plot, another piece of information I want to attach is, I don't know if there is something called infrastructure rating. Where do these countries stand when it comes to the infrastructure? Because I would assume China also, but Japan, Germany, United States to be having far better infrastructure than some of the countries on the right-hand side like India, Indonesia, and Pakistan. Here, it's very difficult to get to remote places and dispense these vaccinations. So if you normalize these with their infrastructure rating, then you can see where the people are really working hard in getting the population vaccinated. So a lot of insights you can gain from just data analysis right there. Okay, now let's look at the country with most vaccinated people. We already did that. China is the number 1, India is number 2, US number 3, but now let's go ahead and plot it. That's all we're trying to do here. And there you go. China, India, US, Brazil, Japan, and so on. The same thing in a different just in a plot way, so we can easily understand this. Okay, now let's look at the actual vaccines itself, like what vaccines are being distributed the most. I would assume whatever vaccines are in China are the ones that are probably distributed the most. This could be Sinopharm. I know a couple of them. I know there are a couple of variations of that. One is Beijing one is Wuhan one. We'll look at that in a minute. So since we want to look for the vaccines, like based on the vaccines, we have to group by vaccines. Okay, and then sort them based on total vaccinations in a descending order. So let's go ahead and do that and print them out. As you can imagine, yeah, Sinopharm Beijing and Sinopharm Wuhan, CanSino, Sinovac, and I don't know about this ZF 2001, but obviously these are the ones that people got. And then comes the Covaxin, Oxford AstraZeneca, and Sputnik from Russia, based on the name, I believe. And US, of course, the ones that we are given in the US are Johnson & Johnson, Moderna, Pfizer. I got Pfizer. So that's what most people got in the US. Again, another type of information that I'm trying to get from here. Now, you can plot them. Again, let's go ahead and take this for the top 10 countries. Again, I'm using this iLock to get the top 10. This is basically the top 5 when you do .head. I'm just getting the top 10, and these are the top 10. And let's go ahead and plot them. Let's go ahead and, by the way, what I'm trying to do here is, if you look right here, the vaccines is our index. I don't want that because it makes it a bit easier and more flexible if I have vaccines as regular part of the data and not as index for plotting purposes. That's exactly why I'm resetting my index, which makes the index to be 0, 1, 2, 3. And let's go ahead and plot it so you guys see. There you go. The vaccines is now the first column, and the index is 0, 1, 2, 3. I'm showing you many things in pandas by walking through. So I'm hoping you guys are learning 2 things. One about pandas, one about the actual vaccines. I don't know why you tuned to this video, but hopefully there is a good balance right here. Okay, now let's go ahead and plot these vaccinations, and we are going to color them by country. And let's do that. And China would probably offset the scale completely. Yeah, as you can imagine. So this is the ones that are given in China, and these are the ones in India. Why did it give? I was wondering why it gave India that color. It's almost like intentional, because whenever you see India represented, it is that color right there. Okay, and yeah, so these are all the different vaccinations that are given. Sorry, I got hung up on this color. I was expecting Pakistan to be this dark green, or that they typically are represented, especially when you guys play cricket. By the way, congratulations on your great cricket the last couple of weeks when it comes to these 2020 in Dubai. So guys are playing amazing. Okay, sorry for deviating right there. And finally, let's end this with a bang. I'm going to use Plotly right there, Choropleth, to put some information onto a map and to color code each country based on certain parameter. In this case, I picked total vaccinations per 100, which is a good metric when you're comparing different countries, how different countries did when it comes to vaccinating their population. You may see some of the small countries, they're all very nice, and some of the large countries, it's very difficult to vaccinate. But either way, let's go ahead and do that. So it's PX is my Plotly right there, and within Plotly I have my Choropleth, and this is my data frame, and I'm resetting index again. And locations, how does it know what locations? I'm using our ISO code. This is the one for India, it's IND, and USA, and so on. I think not much else to explain. Yeah, what color scheme am I using? I'm using an electric, which I believe goes from dark to this bright goldenish white color. So that's what that is. It makes it easy to visualize. This can slow down your browser, especially if you are using Chrome. But let's give it a second to show up and have a quick look and stop this video. I know this is long, but I hope you guys are finding this to be useful. And if you're still hanging out, yeah, I'm pretty sure you find this to be useful. So there you go. That's the plot. And unfortunately, the part of Central Africa is not doing a good job in getting these vaccines. This is where World Health Organization should step in and get these people vaccinated, and other countries. This is slow. You see, it's taking time to exit. Okay, other countries that are not doing good. Afghanistan, I can see, Iraq, and the one next to Iraq is that Syria. and Saudi Arabia seems to be good, and Yemen is not good. Yeah, so find your country here and see how good they are doing. As expected, some of the small countries, you look at Western Europe, these guys are usually pretty good. And Northern Europe, Russia is somewhere in the middle. Again, US, I think overall it's heading in the right direction. So I'm very hopeful, especially about the Central Africa. Every time I do these type of maps, it's disheartening to see Africa being left out. So if any of the viewers out there from Africa, I feel your pain, guys. Hopefully you get these vaccines and everyone would be out of this. So sorry for getting a bit almost emotional over there. I hope you guys found this to be useful. And again, the whole point of this is find the data that you want to analyze and practice pandas. Practice. I suck at pandas, I should say. I do good. I always refer to somewhere online and then refresh my memory because I don't use it on a daily basis. But if you use it on a regular basis, great. If not, find something once a month. Financial data, COVID data. Well, there's a lot of data out there. Just go to Kaggle and search for some data that you can relate to and just practice and practice and practice. Okay, guys, thank you very much, and hit the subscribe button, like button. You know the drill. Thank you.